Hey guys, hi, welcome back. So in this video, we will see the previous year questions of CSIR Net. These all questions are of probability. So here, if you see, I have done all the questions up to 2019 June. So if you see here, there are almost 20 questions. Okay, some of the questions are done in lectures also, but I have repeated the questions here so that for the students who are just watching the previous year questions, it will be convenient for them to get all the questions in the single video. Okay, so let's start with the first question here. It is said a unbiased dice is thrown 3 times successively. The probability that the number of dots on the uppermost surface add up to 16 is. So you are having an unbiased dice. Okay, it is thrown how many times? 3 times. Okay, you will have to calculate the probability that the number of dots that you are getting in the uppermost surface, it will add up to 16. So the formula for probability, we know it is favorable divided by total, right? So in this case, if you see total will be how much? 6 cube, because you are having what? 3 times. A unbiased dice, it is what? Thrown 3 times, so it is 6 cube. So it is 216. Now we will come to favorable. For favorable, you need the sum to be 16. Okay, for the uppermost. So you see, how is that possible? If you're getting first 2 6, then 4, right? Or you will get 6 4 6, or you will get 4, then you will get 2 6. This, and either you will get what? 5 5 6, or you will get 5 6 5, or you will get 6 5 and 5. So total outcomes here favorable, it is how many? 6, right? So therefore directly you can write the probability is what? Favorable divided by the total. So 6 36 times it will cancel, so it is 1 by 36. Clear? So this was very easy. The questions are not tough. The only basic concept must be clear. Okay, now we will see the next question. Question number 2. Here it is said a ball is picked at random from one of the 2 boxes that contain 2 black and 3 white balls, and 3 black and 4 white balls respectively. What is the probability that it is white? So ball is picked randomly. Okay, you are having 2 boxes. Okay, from the 2 boxes the ball is picked randomly. The first box is containing 2 black balls and 3 white balls. So I'm taking it to be the box 1. This is the box 2. All right, the first box is having how many balls? Black, 2 black balls and 3 white balls. In the second box, you're having 3 black balls and 4 white balls, right? This is what it is there. Now you see, ball is picked randomly. Okay, so the probability will be 1 by 2, right? For both the boxes, the probability will be 1 by 2. Now you see, for both the boxes, either here you are asked to find what is the probability that the ball is white. Okay, you will have to calculate the probability that the ball is white. So for this, you see, for the white ball, if you see, if the probability for the ball to be white, the total is what? Total is 5, and here you're having 3. So it is 3 by 5. So the probability for the black ball will be how much? The same, it will be 2 by 5 here. For the second box, if you see here, for black ball, it will be what? 3 by 7. Total is 7. Favorable is 3. For the white ball, it will be how much? It will be 4 by 7. Right? So these are the probabilities. This is for white ball. This is for black ball. This is white and this is black ball. Okay. But you need the probability for the white ball, right? So for probability for the white ball, okay, that the ball is white. So what will be the probability? You randomly from both the boxes, it can be picked, right? So for this, what you will do? Probability, first it is probability, okay, that the ball is from the box 1 and it is white, plus the probability that the ball is from the box 2 and it is white. This is what you need. Okay, this is giving the probability that the ball is from the box 1, but it is for black ball, this is for white ball. Similarly, this is for black ball, this is for white ball. So here you will do what? Probability that it is from the first box. So from the first box, the probability is half, and from the second box also it is half. Okay, 1 by 2. So 1 by 2 you are writing here for both the boxes. Now that the ball is white. So for white ball, for the first box, the probability is how much? It is 3 by 5, and for the second box, it is how much? 4 by 7. So now let's do the calculation. So here if you see half, you can take common. Okay, so half I'm taking out. LCM 5 7s is what? 35. So here you see 7 3s is 21, plus again here you will have what? 4 5s are 20. So when you will do, you will get 41 by 70, right? So the correct option is option B. So the questions are quite simple. The only thing is that you will have to just see what the question is asking and what you are having. Okay. Now you see in the next question. So here what it is said, in a series of 5 cricket matches, one of the captain calls head every time when the toss is taken. The probability that he will win 3 times and lose 2 times is. So this question we have done in lectures also. So here 5 cricket matches are there. That means the number of trial, independent trial, which is denoted by n. It will be 5. Okay. And captain is calling head every time. You're asked to just calculate that he will win 3 times and lose 2 times. So number of successes are here. Okay. And the probability for getting head and probability for not getting head means probability of success in each trial and probability of failure in each trial. It is 1/2, right? N is given to you. N is how much here? 5. Okay. Number of success is denoted by R. It is 3. Okay. So this is binomial distribution formula for probability of R, that is the probability of success. It is n combination R, right? P to the power R, Q to the power n minus R. So this is 5 combination 3. This is 1/2 to the power 3, and this is 1/2 to the power 2. Okay. So when you will do this is factorial 3, 4 into with 5. Here also factorial 3 into with 2. And this will give you what? 1/2 to the power 5. 3 gets cancelled. This is 2 2s are, right? This is what you are having in this case. So if you see this 2 will cancel 1 2 from here. In the numerator you will have 5. In the denominator 2 to the power 4 will give you 16. Clear? So the answer is 5/16. So these are just formula based questions, and you will have to see which term is n, which is r, and you will see the parameters, and then just you can put in the formula. All right, now we will see the next question. So what it is said here, consider 3 parts A, B, and C with an attribute S that can take, here take is missing, okay, to value plus minus 1. Let SA is equals to 1, SB equals to 1, SC is equals to minus 1 at a given instant. In the next instant, each S value can change to minus S with probability 1/3. So the probability that SA plus SB plus SC remains unchanged is what? So the question is very simple. We are having 3 parts A, B, and C. Okay, and the attributes are S. So you can write this as SA, SB, and SC. Okay. Now you see here it is said they can take the values of what? Either +1 or -1. These two values they can take. And it is given to you SA is 1, SB is 1, and SC is -1. So you can say it is 1, it is 1, it is -1. At a instant it is these values are given for that. Now in the next instant it is said that if S will change to -S, okay, and the probability of changing is what? 1/3. Then you will have to calculate the probability that SA plus SB plus SC will remain unchanged. So for the given values, if you see here SA plus SB plus SC, it is what? It is 1, right? The sum will remain 1. For that you will have to calculate the probability. Okay, so here you see that in the next instant each value of S can change to -S for changing. Okay, probability for changing is S. Okay, I'm denoting it by P prime S. It is 1/3. So probability for not changing will be how much? It will be 1 minus 1/3. That is 2/3. All right. Now you see in the first instant it is 3 are unchanged. Okay, all of these are unchanged. So this is the first one. Okay, for the second condition, if you see, if I'm writing SATB equals to what? In this case, this is 1, I'm writing it to be -1. Okay, here I'm writing SB to be 1, and if here I'm writing SC to be what? 1. Okay, so here if you see SA is also changed, it is unchanged, and this is changed. Okay, then you will get the sum to be 1. Yes or no? SA plus SB plus SC. Once you're getting here, second means the first is when 3 are unchanged, the second is when 1 is changed, okay, SB is changed, and 2 are, sorry, 1 is unchanged and 2 are changed. And we will see for the third one. For the third one, if I'm writing SA to be 1, if I'm writing SB to be -1, I have changed, and SC to be what? 1, it is changed. Okay, that is, this is unchanged, this is changed, and this is changed, right? This is one you do, because if you see this was 1, so it is 1, so it is unchanged. This is 1, this is -1, this is -1, this is 1. So these are the 3 conditions when you will get the sum 1. Only these 3 ways are possible na, of changing. but you will have to keep the sum to be constant. Now you see, you will have to calculate the probability the sum is constant. So we got three things here. Okay, three instances we are getting. Now we will calculate the probability of not changing. Okay, so first you see, all of these three are not changing. Probability for changing is 1 by 3. Probability of not changing is 2 by 3. So for this, it will come what? 2 by 3 into with, again, it will come 2 by 3 into with 2 by 3. Okay, plus for this is changed, right? So probability of changing is how much? 1 by 3. Probability of not changing is 2 by 3. Again, probability of changing is 1 by 3. Plus the last one is what? Probability for unchanging is what? Not changing. This is for changing. It is 2 by 3. Okay, probability for changing is 1 by 3 and 1 by 3. Okay, so from here when you will calculate, in the denominator you will have 27, right? This is 2 2s are 4, 4 2s are 8, plus this is giving you what? 2, plus this is giving you what? 2. So all right, so when you will do the simplification of this part, so you will get P is equals to what? 8 plus 2, 10, and then 12. So it is 12 by 27. Cancel, 3 4s are 3 9s are. So it is 4 by 9, right? So the correct option is option D. These are very simple. Just what is given in the question that you need to understand. Okay, now we will see the next question. So question number 5 here, it is said a loaded dice has the probability 1 by 21, 2 by 21. It is up to 6, okay, for turning up 1 2 3 4 5 and 6. So if it is thrown twice, what is the probability that the sum of the numbers that turn up is even? So the probability is given to you for a loaded dice. Okay, for 1 it is 1 by 21, for 2 is 2 by 21, and so on. So you are just asked to calculate the probability that if the dice is thrown twice, that the sum of the numbers that you will get, it will be even. Now you see, when the sum of the numbers will be even, either both the numbers should be what? Even, right? Or both the numbers should be odd, right? That means either if you get 2 2, 3 and 3, okay, if you get 1 and 2, that is one odd and one even, then it is not an even number, right? So you will just do what? You will find the probability for even and for odd. So this is very simple. The probabilities are given to you. So probability for even, okay, and probability for odd, we will calculate. Okay, so for even it will be what? 2 by 21 plus 4 by 21 plus 6 by 21, and for odd it is what? 1 by 21 plus 3 by 21 plus 5 by 21. So finally this will give you 21. Here you will get what? It is 12, and from here you will get 9 by 21. So this is probability for even. Okay, this is total probability for even. Now you need probability that the sum is even. So for that, it's simple. Probability for even plus probability for odd you will do. That means you will just multiply this. This is probability for what? For one dice. Okay, so it is 12 by 21. So for two dice, again you multiply 12 by 21 plus, again here you are having what? 9 by 21 into with 9 by 21. In the denominator you will have 441. This is giving what? 12 12s are 144, right? Plus, and this will give you what? 9 9s are 81. So this will give you 225 divided by 441. Calculation you can do on your own. So the correct option is option C. This we have done in lectures also. You can go and check it out there as well. Now we will see the next question. So question number 6, it is said a child makes a random walk on a square lattice of lattice constant A, taking a step in north, east, south, and or west direction with probability 0.255 in north and east and 0.245 in west and south. So after a large number of steps and the expected position of the child with respect to the starting point is at a distance what? So this question already we have done in lectures. So square lattice is there. So we'll just consider this is x-axis, okay? This is y-axis. This is negative x, this is negative y. So you see here, this is east direction, this is west, this is north, and this is south. Now you see lattice constant is A. Okay. So that means what? Each side, the distance that it will travel will be A. Means each side of the square is what? A. Okay. So now you see probability for east, it is how much? 0.255. For north also it is 0.255. For the other two sides it is 0.245, 0.245. So directly we will use the formula of mean, right? This is for one step and then we will multiply with n to get for n steps. Okay. Now you see this is summation I. All right. This is xi pi. Okay, so the probabilities you will see first, we will see for which direction. Let's see for the north direction. Okay, so this is 0.255 j cap, right? This is the probability and this is j, and in all of them you will get a, so I will write one a outside. Okay, here now you see next it is for what, for the east direction, so it is what, 0.255 I cap, right? Again you will write minus, these are negative. Okay, this is negative x-axis, this is negative y-axis, so it is what, 0.245 I cap minus 0.245 j cap, right? When you will subtract, okay, you will get what, you will get 0.010, right? A 0.010, and here you will have what, I cap plus j cap. You can just do and see. Okay, when you will do so, you can calculate it on your own. So when you will get this, if you see now, if you do this for what, n, okay, mean value for n, so you will get n a, right? 0.010 I cap plus j cap, right? This is what you will get. So you see here in this case, I cap plus j cap means this one, so it is in the direction what, northeast. Okay, so this will give you the northeast direction, and you can write it as what, this is 0.010. You can write it as what, this is just very simple. You can, if you will calculate this and when you will do it entire na, so you can write it to be equals to what, 10 to the power minus 2, right? And when you will just calculate the magnitude, you know, I think this is, you know, a I cap plus b j cap. When you will do this, you will get what, it is a square plus b square, so it is 1, so you will get here root 2, right? So it is 10 to the power minus root 2, 10 to the power minus 2 into with root 2 n a, and it is in the northeast direction. Simple. So the answer will be what, root 2 into 10 to the power minus 2 na in the northeast direction, that is option A. Clear? So these are very simple. This is not complicated. And if you're having any problem, you can go and check the lectures as well. Next, you see in one dimension, a random walker takes a step with equal probability to the left or right. What is the probability that the walker returns to the starting point after 4 steps? So this question also we have done before. So this is also quite easy. Okay. So I will not explain with the entire thing that I have done in the last video. This I will do in a direct way only, because how we were calculating, okay, the basic formula way. So if you're having any problem in the formula, so for random walk, we know the probability formula is there. Okay, probability was what, n combination n1, right? P to the power n1 and q to the power n2. So here you know n is equals to steps of equal length along a line, right? And what, it is the number of steps taken to the right, and to the numbers of steps taken to the left, and p represents the probability of taking step in right and q taking in the left. Okay, so here in one dimension, here it is said a random walker, it is taking a step with equal probabilities to the left and the right. That means the probability is 1/2 for going to the left also and for going to the right also. So here p is equals to q, it is 1/2, right? And here capital N, it is 4, because you are asked to calculate it for what, that the probability that the walker returns to the starting point after how many steps, 4 steps. So n is equals to 4 here. So rest all other things are clear. You will see n1 and n2 will be also 2, right? Because for 4 steps it will take what, equal probabilities means equal steps it will take on either side, left and right. So directly probability for 2 comma 2, okay, 2 steps in the left and right, it will give you what, 4 combination 2, 4 steps, okay, combination 2, this is what you will write, and this is 1/2 to the power 2. Directly I'm just putting the formula, this is n 4, n1 is 2, so this is 1/2 to the power 2, this is 1/2 to the power 2. Just calculate it, you will get 2 3 into with 4, okay, this is factorial 2 into with 2, this is 1/2 to the power 4, this is 2 2s are, so finally we'll get 3 to the power 3 by, if you will see, 8. Just calculate and see directly. If you are having any problem, you can go to my video of random walk, and there you can see how I have explained this term with the help of a proper chart. Here I'm not doing that directly, I'm using the formula. Clear? Now let us see the next question. Question number 8, two independent random variables m and n, which can take the values, integer values 0 to infinity, okay, any value, follow the Poisson distribution with distinct mean values mu and nu respectively. Then out of the 4 options, what is correct? Random variable m and n is given to you values, it can take any value, okay, which can take the integer value 0 to infinity. Now you see Poisson distribution is followed. So when you are discussing about Poisson distribution, the mean is given to you. We know that in case of Poisson distribution, the formula for mean is NP and the formula for variance is also what? NP. It is same. Now you see here the mean for M it is given mu and the mean for N it is given nu. Okay. So the first one you see, it will be a Poisson distribution because if you see here in this case, here if I write the variance, okay, for M plus N, okay, for M plus N, then I can write it as mu plus nu. Yes or no? Because this is the variance for what? M and this is the variance for N. Yes or no? So you see the variance of the random variable R, okay? This is for the random variable R. It is M plus is equals to M is what? M plus N. It will be equals to mu plus nu, right? So this is what we are getting. So it is the variance of random variable R is equals to M plus N. It is equals to mu plus nu. Directly you can do on the basis of formula. Question number 9, a random walker takes a step of unit length in the positive direction with probability 2/3 and a step of unit length in negative direction with probability 1/3. The mean displacement of the walker after n steps is what? So the question is related to asymmetric random walk, right? So if you see here, the probability is what? 2. It is taking unit step in the left and right. Okay. The probability for right it is 2/3, for left it is 1/3. You are asked to calculate the mean displacement after n steps. Okay. Suppose if he is at this point, okay, initial point, and he is taking 10 steps to the right. Okay. He took this many steps to the right. Now, if he is taking 3 steps to the left, okay, 3 steps back, what you will do? You will just subtract and then you will get its displacement or not from the initial point. Okay, mean displacement, this is how you will get. So here you see probability for the right, okay, is what? 1/3. Total steps given to you is what? Total steps is capital N. It is equals to what? Small n here. So finally you will write total displacement. Total displacement will be what? Taking the step in the right minus with the left. Directly from subtraction you will get, and you will multiply with n, okay, for n steps, okay, because you are asked to calculate after n steps. So this is what? This will give you, when you will take the LCM, you will get 1/3 n. Okay, calculate and see. So the direct answer is 1/3 n, or you can say n/3. Clear? This is what it is. Now we will see the next question. So question number 10, here it says, consider a random walker on a square lattice. At each step, the walker moves to a nearest neighbor side with equal probability for each of the 4 sides. The walker starts at the origin and takes 3 steps. The probability that during this walk, no side is visited more than once. Okay, this is once. So a random walker is there on a square lattice. So let us consider a square lattice here. This question already we have done in the lectures. Okay. So if you see, this is a square lattice. I'm considering the walker to be at this point at the origin. Now you see, at each step, the walker moves to a nearest neighbor side with equal probability of the 4 sides. Means he can go to any of these 4 sides. Okay. With equal probability, it can go. Okay. He can go to this side also, this also, this also, and this also. Now you see, the worker starts at the origin and takes 3 steps. Means he is starting at this point and he will take 3 steps. You will have to calculate the probability that during this walk he cannot visit one side more than once. Okay, so just it is simple, just 3 steps you will have to calculate for 3 steps. So total ways, if you see the total ways for 3 steps total, okay, it will be 4 cube, right? Because it can go to any direction. Now we will calculate for favorable ways. So all the 4 steps you can see, for total all the 4 steps it can take any 4 directions. Now the condition given to us, okay, after 3 steps. So at the first position it is what? It can take any 4 sides. So it is what? 4. Okay. For the second step, he will be at this position. Now you see, it is said he will not visited any side one, means he will not visit one side twice. Okay, more than once he cannot visit. That means he cannot come back to this position. Either he will go this side, or this side. Now he's having what? Total number of sides 3. For the next time, if you see, he is coming back here. Again, he will have what? 3, right? So this is simple. Directly you can see on the basis of analysis. So here if you see, this will give you 64, right? And this will give you what? 36. So the probability is what? Favorable divided by total. So directly when you will cancel, 4 nines are 4 16s are. So 9 by 16. Clear? Correct option is option D. Done. Now let us see the next question. Now let us see question 11. It is said let x and y be two independent random variables, each of which follow a normal distribution with the same standard deviation sigma, but with mean plus mu and minus mu respectively. Then the sum x plus y follow a random variable x and y is given to you, which are independent. They are following normal distribution. Okay, standard deviation is sigma for both of them, but mean is plus mu for x, minus mu for y. So you will see you're having 4 options here. So directly I'm saying distribution with 2 peaks. When we are talking about 2 peaks, it is not possible in case of normal distribution because we know it is a unimodal curve. Similarly, the option C is also not possible. We will see the option B and D here. Okay, so first of all, you see here, standard deviation is given sigma, right? So you see here in this case, mean. First, we will see the total mean. Okay, mean mu prime is what? Mu x plus mu y. It will be mu minus mu, so it is 0. Next, you see the variance, sigma square. Variance is what? The square of the standard deviation. So you can write here what? Sigma x square plus sigma y square, right? So it is sigma square plus sigma square. So it's 2 sigma square. And the standard deviation for this will be what? For x plus y, you can directly write, it will be, directly you can write sigma prime, it will be equals to what? It will be equals to root 2 sigma. That means it is a distribution. Okay, it is a normal distribution, right? With mean 0 and standard deviation sigma root 2. So the correct option is option D. Clear? Next question, question number 12. Here it is said the random variable x. Okay, here x is greater than minus infinity but less than what? Infinity. Is distributed according to the normal distribution. Px is equals to 1 by root over 2 pi sigma square e to the power minus x square by 2 sigma square. The probability density of the random variable y equals to x square is. So random variable x is given to you. X is greater than minus infinity, less than infinity. And it is distributed according to what? Normal distribution. Okay. So what is given to us? Probability P x. It is 1 by root over 2 pi sigma square e to the power minus x square by 2 sigma square. We will have to calculate the probability density, which we can directly calculate. The limit for x will be minus infinity to plus infinity, right? And this will be what? Px dx is equals to 1. This is how we are calculating. You can see the lectures if you're having any problem. That means we're writing fx dx minus infinity to plus infinity equals to 1. So here if you see 1 by root over 2 pi, right? Sigma square. This is constant, I'm taking it out, and here I'm writing minus infinity to plus infinity e to the power minus x square by 2 sigma square dx, and this is equals to 1. Now you see here, it is what? Y is equals to x square. So when you will differentiate, dy is equals to what? 2x dx, right? So from here you can write what? 2 dx, it is equals to what? Dy by 2. Okay, this is what it is directly. So directly we will substitute here. In this case, when you will substitute, just a second, we will not have written the same thing here. Okay, now you see these are the things given. Now y is equals to x square, dy is equals to what? 2x dx. So from here what you can write, in this case you can write, you see, in this case x is equals to what? Root y. This is what it is. So here if you see, if I write here x dx, it is equals to what? Dy by 2. Okay, and I can write dx is equals to what? In this case, dy by root y 2. Yes or no? Because x is equals to root y. This is the value of dx. We will just substitute here. Okay, and you see we will change the limit from 0 to infinity. So here you will have 1 2. Denominator will be 2 pi sigma square e to the power minus x square means minus y. X square is equals to y by 2 sigma square. This dx will give you what? Dy by 2 root y. This is equals to 1. So 2 and 2 will get cancelled here. No, so finally you will have 1 by root over 2 pi sigma square. Right? This is what you're having. And integration is what? 0 to infinity Here you write e to the power minus, what you will have, y by 2 sigma square by root y dy. Clear? This is what you are having. The entire thing we have just substituted. Okay, and this is equals to 1. Now if you see here, what will be the conclusion in this case? That y is what? Y is greater than 0, right? Greater than equals to 0 but less than infinity. This is what you will see from this condition. Y is greater than equals to 0 but less than infinity. And you are having here what? 1 by root over 2 pi square sigma integration 0 to infinity, this one. So when you will check the options, it is 1 by option A, 1 by root over 2 pi sigma square e to the minus y by 2 sigma. Y is greater than equals to 0 but less than infinity. In this case, you see, if y is what? Greater than equals to 0 but less than infinity, but this term is not matching. Here also this term is not matching. Here this term is not matching. So this is how you can just conclude. We have just used the probability density formula, okay? Normal distribution, okay? It was given to us, okay? Px is equals to what? You are calculating probability density of the random variable x. Limit of x was given to us. Directly you can do. If you're having any problem, you can go and see the lecture also. That will make you more clear about the concept. Next, let us see question number 13. A random variable n obeys Poisson statistics. Okay. The probability of finding n equals to 0 is 10 to the power minus 6. So the expectation value of n is nearest to what? So this is what you are asked to calculate. Expectation value means we know mean value. We have to calculate it for what? Random variable n. Okay, and the variable is obeying Poisson's statistics. So for Poisson statistics, we know the probability formula. Probability of r, it is what? E to the power minus m to the power r, right? Divided by factorial r. Okay, so here you see r is equals to n in this case. So probability for what? 0. Okay, for n equals to 0, what you will see here? It will be e to the power minus m to the power r is here n, that is 0. So you can write directly what? You can write directly m to the power 0 is 0, factorial 0 is also what? 1. So it is e to the power minus m. Now you see, here it is said what? The probability for n equals to 0 is 10 to the power minus 6. That means you will write 10 to the power minus 6 is equals to e to the power minus m. Now when you will take log, you will write minus m, it is equals to what? ln 10 to the power minus 6, which can be further written as minus m, just solving it, okay? Minus ln to the power 10, this is minus 6. Minus n, minus will get cancelled. M is equal to 6 into ln 10 value is what? 2.3. So when you will do, you will get 13.8, which can be written as approximately 14, just to match the option. Clear? So it was not tough. We have just seen the formula of probability because the probability was given to you. The formula we have seen what is the parameters given to us in the question. Okay. Next, here it is said 12 balls, 3 each of the colors red, green, blue, and yellow are put in a box and mixed. If 3 balls are picked at random without replacement, the probability that all 3 balls are of same color is what? So here you see you are having 12 balls. Okay, 3 are of each colors, red, green, blue, and yellow, and they are in a box. Now you see here it is said randomly you are picking up 3 balls without replacement. Means if you are picking up 3 balls, you are not keeping it back. Okay, you will have to calculate that what is the probability that all the 4 balls will be of the same color. So the same thing we will use favorable divided by total. So you will see total balls in this case is how much? It is 12. Okay, in our case. Clear? Now we will see total number of ways is what? For this case, total number of ways. So it is simple. Total is 12 combination. We can pick 3 at once. Okay, randomly. So it is 12 combination 3. Next is favorable way. Favorable way will be how much? 4. Yes or no? Because if you are taking how much? You need what? 3 of same colors. You're having 4 colors here, right? Red, green. So either it can be what? 3 red, 3 blue, 3 green, 3 yellow, right? So it is what? 4. Clear? So now we will do what? 4 divided by 12 combination 3. So calculate the value of this. This is factorial. 9 into it, 10, 11, 12. Here you're having factorial 9, right? And in the denominator 2 into it 3. 9 gets cancelled. This is what? 2 6 are, right? This and this is 3. twos. When you will get this to be 220. 11 twos are 22 and this is 220. So finally probability, okay, probability for what? Same color as I'm writing. So it is 4 by 220. So 4 5s are 5s. 1 by 55 is the answer. So the correct option is option D. Clear? Just you need to understand total and favorable correct conditions. Next, it is said a canal system is shown in figure. Water flows from A to B through two channels. Okay, gate G1 and G2, they are operated independently. To regulate the flow, probability of G1 to be open is 10% and that of G2 is how much? 20%. So the probability that water will flow from A to B is what? So you are having a canal system. This is a canal system shown. Water will flow from what? A to B. Okay, and it will flow through two channels. Now you see G1 and G2, they are operated separately. For the probability that for the opening of G1 is 10% and for the opening of G2 is 20%. Now you see water, you need to calculate the probability that water will flow from A to B. Under what conditions will water flow from A to B? Either only G1 is open or G2 is open or both are open, right? In these three conditions, water will flow. Otherwise, the water will not flow. So now you see probability for what? Opening of gate G1, it is 10%. So it is 10 by 100. So it is 1 by 10. Probability for what? Opening of gate G2, it is 20 by 100. So it is 2 by 10, right? Now probability for not opening, okay, I'm denoting it by P prime. So PG1 is what? Total probability is 1. So 1 minus 1 by 10, it will be 9 by 10. And P prime G2, it will be what? It is 1 minus 2 by 10. So it will be what? 8 by 10. This is for not opening. This is for opening. Now you see probability for what? That water will flow from A to B. So we will use these three conditions. First, we will see what? First, we will see gate G1 is open. Okay, probability for opening of G1 and probability for closed of G2. Okay, so it is 1 by 10 into with what? 8 by 10 plus. Now, probability that first one is G1 is closed and G2 is open. So it is 9 by 10 into with 2 by 10. Last is what? When both are open. That is what? 1 by 10 into with 2 by 10. Right? So denominator you will have 100 and here you will have what? 8 plus 18 plus 2. So this is 28 by 100. Right? This is what you are having. So when you will convert this into percentage, you can write directly. This is giving you 0.28. When you will convert it to percentage, this is 28%. Okay, the probability that water will flow from A to B is 28%. Clear? So this option is 28. I wrote by mistake to be 20. So now here you see, here it is said in the following circuit, each device D may be an insulator with probability P or a conductor with probability 1 minus P. Probability that a non-zero current flows through it. So you are having this circuit, okay? Device D, it can be insulator or a conductor. Probability for insulator is P, for conductor it is 1 minus P. So for this circuit, to flow how much? For a non-zero current flow, okay, you will have to say that what is the probability that this circuit will have a non-zero flow of current. Now you see when this circuit will have a non-zero flow of current, first this must be a conductor, right? And out of this three, one must be a conductor, otherwise how current will flow? Okay, they will be, because we are looking for non-zero current. So now you see, if I take probability is equals to what? This must be a conductor, that at least this is a conductor. So I'm denoting it by what? PA plus probability of B. Now this probability of B, or you can write PT, whatever notation you're taking, P2 will denote that at least one of these three must be a conductor. Okay. It can be two also, it can be three also, but you need only one should be a conductor for this circuit to give you a non-zero current. Now you see, when we are talking about at least one should be a conductor, what we are doing, we are subtracting 1 minus with what? None of them is a conductor, right? Because how? Because we know probability is what? Success per failure. Either it's a conductor or it's not a conductor, right? So now you see for this one, for the first one, if you see probability that this is a conductor, okay, it is 1 minus P, total probability minus with the probability that it is a what? Insulator. So this will give you the probability that it is a conductor. Okay, this is into. Next you see probability that at least one is a conductor out of this tree. So this is also 1 minus what? that none of them is a conductor. So probability for the first device to be an insulator is P. For the second also it's P. For the third also it's P. Right? So it is 1 minus P into with 1 minus PQ. Clear? There is probability that this device is a conductor and probability that at least one of these three devices is a conductor. The multiplication of both will give you that the non-zero current will flow through this circuit. Done? Let's say question number 17. It is said at its step, a random walker in one dimension either remains at the same point with probability 1/4 or moves by a distance delta to right or left with probability 3/8 each. After n times its root mean square displacement is what? So simple question. This is a random walker in one dimension. Suppose he's starting with this point. The probability that he will stay at this point is 1/4. To move left, I'm considering minus delta. To move right, I'm taking delta. Okay, as in number line. Okay, plus minus the displacement. So you see probability for remaining in the same place is 1/4. To move left, it is 3/8. To move right, also it is 3/8. You're asked to calculate the root mean square displacement after n times. So first we will calculate for one time. The root mean square is what? This is root, this is mean, and this is the square. X is denoting the displacement here. So first we will calculate this, the mean of x square. So the formula is summation xi square pi, right? So we will start with the right. So the x, the displacement is what? Delta square. Probability is 3/8. For the second, it will be 0, right? Okay, and for the third one, it will be what? Minus delta square, 3/8. Now you see delta square, this will give you what? 6/8. When you will cancel, you will get it to be what? 3/4. Okay, now for n times, okay, you will see this for n times, for n steps, okay. So this will give you what? 3n/4 delta square. And the root mean square for n times will give you what? X RMS. For n times, it will be root over 3n/4 delta, right? So the correct option is option C, root over 3n/4 delta. Now let us see question number 18. So here it is said a multiple choice exam has questions, each has 4 answer choices. Every question is having one correct answer. The probability of getting all answers correct by independent random guesses for each one. Independent random guesses, okay. So it's very simple. We have done in exams also. We are having one MCQ and it is having 4 options. So basically we see one answer is correct, okay, generally. But here you are asked to calculate the probability that all the answers are correct by independent random guesses, okay, for independent random guesses. So if I'm taking for 4 options, for the first option, the probability that it is correct for the first option A, it will be 1/4. For the second also, it will be what? 1/4. For the third one, it will be 1/4. For the last one, it is be 1/4. Means you're having 4 conditions favorable divided by what? Total. So it is 1/4 for the first. Second, favorable divided by total. Favorable, it is 1/4 whole to the power 4. The other way also you can see total number of ways will be what? Independent. So you will have what? 4 options and four options. That means it is 4 to the power 4. Right? This is total. And favorable will be what? 1. Yes or no? Because out of 4, one probability of getting all answers correct by independent random guesses. So independent random guesses, so favorable will be 1. So it is 1/4 to the power 4. This way you can do it. But this is a easy way. So it is 1/4 to the power 4. Done. Next you see here it is said a box contains 5 white and 4 black balls. 2 balls are picked together at random from the box. What is the probability that these 2 balls are of different colors? So boxes containing 5 white balls and 4 black balls. Again, we will do favorable divided by total, right? So total in this case directly you can write total is what? 9 balls. Randomly you are picking how many balls? 2 balls, so 9 combination 2. Favorable, you see that you need what? Both the balls should be what? Of different colors, right? So you see for the first one that the ball should be white. One ball is white. So it is 5 combination 1, right? And for the other one, 4 black balls, so it is 4 combination 1. This is the favorable because you need different colors, right? So calculate this. This will give you 1. 9 combination, this is 7, 8 and 9. So this is giving you a 2 into with factorial 7. 7 get cancelled. 2 4s are, so this is giving you 36. Here when you will calculate this one, it is factorial 4 into with 5. And rest you can see this is factorial 4. This will give you what? Factorial 3 into with 4 and this will give factorial 3. So if you see it is 20. Directly you can do and see. So therefore the probability is what? Favorable divided by total. So 4 5s are 4 9s. So it is 5/9. Done. So the correct option is option C. Clearly it's clear. Just you will see the total and the favorable outcome, but you will see that this time it is not same but different colors. Now let us see the next question. Here it is said a particle hoops randomly from a side to its nearest neighbor in its step on a square lattice of unit lattice. Okay, square lattice whose of unit lattice. The probability of hooping is hooping to positive x direction is 0.3, to the negative it is 0.2. These are the probabilities. Okay, for positive x direction 0.2, for negative it is 0.3, for negative it's 0.2, and for y direction it is 0.2 and 0.3. So if a particle starts from origin, its mean position after n steps is what? So this is just like the child. Okay, the way we solve for the child one, that only we'll do. So square lattice you are considering. This is what? X. This is minus x. This is y. This is negative y. Now you see probability for positive x direction is 0.3. For negative it's 0.2. For positive y it is 0.2. For negative it is what? 0.3. So particle starts from the origin. Okay, now you see square lattice, the distance unit. Okay, displacement you are taking it to be 1. Okay, for all the cases. Now you see directly we'll see what mean position you need to calculate. So you're having the formula for mean, summation I pi xi, right? So probabilities we will see. First we will see for which direction. For positive x, if you see it is what? 0.3 I cap, because it is 1, right? Plus again for negative, if you see what you will get, 0.2 minus I cap, right? Plus again you will have for 0.2 j cap plus 0.3 minus j cap, right? This is what you're having. So if you see here, from this what you will get, this is 0.3 I cap, this is what? 0.2 I cap. So finally if you see, when you will solve and see, you will get 0.1 I cap minus 0.1 j cap. You can just do and see, this is 0.3 I cap, this is what? 0.2 minus I cap. So minus will come 0.1 I cap. Here also when you will do 0.1 j cap. So you can add 0.1 I cap minus j cap. So 0.1, you can write it as 1 by 10 I cap minus j cap, right? Now you see, you will have to see after how many steps? N steps. So just multiply it with n. So you will get n by 10 I cap minus j cap. Or you can add 1 by 10 n I cap minus j cap, right? So what is the answer here? 1 by 10. The option is B. 1 by 10 n I minus j. Clear? So that's all in this video. These questions are not tough. If you do repeatedly, I think this 20 questions if you do, and if you take any book and solve 5 to 10 questions more, and if you're having a good revision of the formula, then you can solve all the questions of probability. But I would request you that at least you need to read the question twice before solving any questions. It's not only for probability, it's for all the questions when you're attempting any competitive examination. So that's all in this video. Thank you so much. Have a good day.